My name is Peter Okonkwo. I am making a presentation on the design and construction of cooking gas leakage detector. My co-workers on this project are Obi A and Idoko S. The aim of this research is to design and construct a cooking gas leakage detector. The objective of the research is to design and construct a device for detecting the leakage of cooking gas. Background and introduction. We live in the world of sensors, as today sensors have taken over most of the tasks previously performed by humans. The application of different types of sensors in all engineering, design, and homes has made life easier for human beings. For example, most of the tasks that are previously undertaken by humans are now done by sensors. For example, turning on the lights by detecting human presence, smoke detection in factories, room temperature adjustments, and street lighting turning on and off, and even the opening of garage doors at the approach of a car, or in the automatic flight control system in most civilian and military aircraft. In fact, it can be said that without sensors, automation would have been a mirage. The question now is, what is a sensor? A sensor is simply an input device which provides an output signal with respect to a specific physical quantity input. In the olden days, men worked in harmful environments, knowingly and unknowingly, and even when the environment was known to be harmful, risky, and dangerous, causing all manner of injuries and fatalities, people accepted it as part of the risk of the job. The first environment which raised human concerns as a result of fatalities recorded in it was the coal mine. The coal mine was identified as an area housing many combustible and toxic gases which caused dangerous explosions, fire, and even death in mines. This then created the need for developing how to detect the harmful atmosphere that was responsible for the explosion and fire in coal mines, and hence the literature review. Many notable researchers like Dr. Walter O. Snelling have worked on LPG gas. In fact, he was the one that discovered LPG in 1910. This was followed by Dr. Jiru Siju, who developed the first gas sensor based on light wave interference, that is the interferometer, in 1927. Also, another researcher like Dr. Oliver Johnson developed a platinum catalyst in a Wilson bridge electric circuit for the detection of combustible gases in 1929. Other researchers have also worked on gas detection and sensors, and even in the classification of gas detection technology. My co-workers on this project are Obi A and Idoko S. methodology and components. The cooking gas detector is realized using the following main components. The MQ6 message Q6 gas sensor module is the one that senses and detects the concentration of the gas in any environment. The Arduino microcontroller is also used for interfacing all these major components in the device. And for the Arduino microcontroller to perform these functions, it has to be programmed using the Arduino programming language. Then you have the liquid crystal display LCD, which indicates or displays the concentration per parts in millions when the device in operation. Then also you have the light emitting diode, which comes on as an alarm when activated as a result of the gas concentration exceeding a certain specified limit. Then also you have the buzzer, which is an alarm signaling device used in timers and other alarm devices. It could be a mechanical, electromechanical, or even piezoelectric. Then you have the SIM800L GSM module. This component is incorporated so that once the concentration of the gas in a given environment is above the specified limit, it will send alert to the user. Then you have the batteries. Here we use two different types of batteries. The 4.0 volt nickel batteries and 3.0 volt nickel batteries for powering the microcontroller and the SIM module respectively. For the voltage from the microcontroller to be connected to the SIM module, there is need for a step down. And this step down is carried out using equation 1. In equation 1, V out is the step down voltage to the SIM module, while R1 is the 4.07 kilovolt resistor from the microcontroller and connected between the SIM module receiver pin and the Arduino microcontroller. Then the R2P, the R2, which is 2.0 kilo ohms resistor, is connected between the SIM module RX pin and the ground. Vin is the input voltage from the Arduino micro. Then the hardware design. This is the design of the arrangement of the hardware. As you can see, the MQ6 sensor, the buzzer, the microcontroller, the SIM module, and the batteries. Next is the flow chart for the decision making of the microcontroller. The system initializes, and if the quantity of gas in the environment of test is greater than or equal to 200 ppm, the LCD, the LED, and the buzzer will be activated, and a text message is sent to the user. Otherwise, the switches, the buzzer is off, the LED is off, and no SMS is sent. The message queue sensor datasheet. Like the message data queue, the message data sheet is provided by the manufacturers, and is used basically for the determination of the sensitivity of the sensor and also for its calibration. The sensor calibration is effected using equation 4. Here RL is the resistance of the load, In that equation, VC represents the voltage from the microcontroller, while VRL represents voltage from the sensor's rated resistor in the environment of test. The ADC value is the analog to digital voltage from the sensor to the microcontroller. Analysis of the device performance. The fabricated device, when tested for its performance, gave a positive result. This is the device after construction as shown in figure 4. Then figure 5 is the device under test. Now figure 6 represents the device under test when the concentration has exceeded the specified level, and you can see the LED on, and the buzzer is also calibration. The sensor calibration is effected using equation 4. Here RL is the resistance of the load, has been met. Recommendation. Among the recommendations are that the device should be placed close to where it can easily sense the presence of the gas, and it is also advisable that this crucial device should be placed in every domestic and industrial area, because safety is very. Then the hardware is. Thank you.